So this is our last lesson that we have to learn before the challenge exam. And it is on polar coordinates. So this is not something you've ever done before, but it's remarkably similar to things we just learned about vectors and just trigonometry over the year. But before today, the only coordinate system you guys know is the Cartesian coordinate system or the rectangular coordinate system. There is a whole nother coordinate system that's a polar coordinate system that's based off circles. And for the rectangular coordinate system, you go a certain amount to the left and then a certain amount up to get to a point. The polar system takes you directly to that point. So it tells you which direction to go and how far to get there. And you end up at the same point. It's just a more direct way to get there. So the polar coordinate system is made up of the origin, which is called the pole, and the horizontal axis in the positive direction is called the polar axis. Right, and the instead of having, for rectangular you have the x and the y. For polar coordinates you have r and theta, and r is the directed distance, from the pole, and theta is the directed angle counterclockwise from the polar axis. All right, and a few years ago I found these grids that have like just the important angles labeled, and these are in radians. I do have an example kind of towards the end that is in degrees, so it could go either way, degrees or radians. Okay, so let's start off just by plotting some points. So for the first one, we're going to plot the point 2 and pi over 6. So 2 tells you how many circles to move out, and pi over 6 tells you how far to rotate. So we would move 2 circles out, which would be this one right here, and then we would rotate to the angle pi over 6, which is this one. So the only point you have to put is this last one. Now, this is kind of hard for me to do on here because I can't really point. So I probably will make more marks than you have to just to show you how to get there. So that's the easiest way. Ones to graph is when they're both positive. When either one of your coordinates are negative, it does make it more difficult to do. And I'll show you on this next one what to do. Okay, so we all know from past experience that a positive rotation is going to go counterclockwise. So this is a positive rotation. And then a negative rotation is going to go clockwise. So these are both negative rotations. And so what we're going to do in this one is go 3 circles out and then rotate in the negative direction to the same rotation as it would be to go to 2 pi over 3. We have to rotate that in the negative direction. So in the negative direction, that's going to take us, we move 3 circles out. That's going to take us to 4 pi over 3. So this is our point. Now what some people do, because I have a hard time visualizing it, is they count how many marks that is to go around. So to get to 2 pi over 3 is 1, 2, 3, 4, 5. And so what they would do is rotate 5 marks in the negative direction, and then that takes you to your negative 2 pi over 3. Okay, so let's look at C. C is a little different. C, the R is negative. So we're still going to go 4 circles out to start for our rotation, but we're going to go 4 circles in the negative direction. So 1, 2, 3, and then 4. That's where we're going to start. That's not your final point. And then we're going to, from there, we're going to rotate pi over 3 in the positive direction. So again, I want to point you back up to here. The positive direction from where we are now is going to be like this. So normally, to rotate to pi over 3, it's this much of a rotation. Or you could say it's 3 lines. So we're going to rotate that from this point here. So that's going to end us up right there at 4 pi over 3. All right, and then this next one has both negative coordinates. So this is definitely the most difficult kind that you have to do. But you guys, look at it for a second. See if you can figure out where this point would be. Okay, so we're going to start over here, 3 circles out in the negative direction, and then we're going to rotate in the negative direction from there. So a normal rotation to 3 pi over 4 is there. So from this point, I'm going to do that same rotation, but go in the negative direction, and it should take me to here. Right. You also could count lines like we did before. So to get 3 pi over 4, it's 1, 2, 3, 4, 5, 6 lines. And so what you would have to do is starting over on the negative 3 side, count 6 lines. And that's going to take you to that point. Okay, so that's plotting polar coordinates. This last one, we're going to do one in degrees because, like I said, these can be in degrees also. These are both positive, so it's a little easier. So 300. I'm going to go 3 circles out at the angle 300, and there it is. All right, another thing that you guys need to understand is that for rectangular coordinates, there's one point that is the point 2, 1. But these have multiple representations. Like we graphed -3 pi over 4, but obviously it's also 3 pi over 4. All right, and then we could also go out 3, but then rotate in the negative direction. So that would be 7 pi over 4. So I want you guys to know that each point has multiple representations. And then I have up here typed what you go through, the process you go through to get it. And then for all of these, I also want you to know if it's in degrees, anywhere where there's 2 pi, you would use 360 degrees if it was in degrees. And then anywhere where it's pi, you would use 180 degrees. All right, so let's go through a couple of examples of these. We're going to find 3 additional polar coordinates, and we're going to use radians, but just know it works the same in degrees. So the first thing it tells us to do to find another one is keep r the same, and then subtract 2 pi from theta if it's positive, and add 2 pi to theta if it's negative. So our theta was positive, so I would take 3 pi over 4 and subtract 2 pi from it. All right, and then 2 pi is the same as, if we're talking about with something over 4, is the same as 8 pi over 4. All right, so that's going to give you negative 5 pi over 4. All right, so there's one additional representation. All right, then for the second one, it tells us to replace r with the opposite of r. So since our r was 2, we'll make it negative 2. And then subtract pi from theta. So 3 pi over 4. And if we want to subtract pi, that's the same as 4 pi over 4. So an additional representation is going to be negative 2, negative pi over 4. Great. And then for our last representation, we're going to use the previous point. So keep r like it is and use negative pi over 4. Subtract 2 pi from theta if it's positive. If theta is positive, add 2 pi to theta if it's negative. So ours was negative. So we're going to add 2 pi, or 8 pi over 4 in this case. And that gives us our third representation. And all of those would graph to the same exact point. Okay, let's do the same thing with B. So the first representation, you leave r the same, and then you're going to, in this case, since theta is negative, we're going to add 2 pi to theta. 2 pi, if 6 is the denominator, is going to be 12 pi over 6. All right, so there's one representation. The second thing that we can do is take r and make it the opposite. And then take our theta. And because it was negative, we're going to, oh, it doesn't matter. We're still going to go ahead and subtract pi from theta. So pi in this case is going to be, wait, let me look at it again. Oh, let's add that. Sorry. There's something. We need to add a section to this. So we're going to subtract pi from theta if positive. Add pi if negative. So we're going to add pi. 6, it's going to be 6 pi over 6. All right, and then for our last one, we use the previous point where we're going to leave r like it is in the previous point and take 5 pi over 6. And then subtract 2 pi from it because it's positive. All right, there it is. All right, and then this last part is what is specifically listed in your standards for polar coordinates, is to convert them back and forth between polar and rectangular coordinates. So let's start with just talking about what we do if we have polar coordinates. So we have r and theta, and we're going to change it to rectangular coordinates, which is going to be x and y. And this goes back to kind of like what we learned with vectors. So the x is going to be r, which is the distance traveled, times the cosine of theta. And then the y is going to be r times the sine of theta. Now your theta can be in degrees or it can be in radians. These are all radians, but just know that polar coordinates can be in degrees, like I've said before. So for example 3, we have r and theta. We want to change it to x and y. So for the x, we're going to do the r, and we're going to multiply it by the cosine of theta, which in this case is pi over 2. All right. For pi over 2, we technically can use the hand trick if you want to, or you can use the unit circle. I just want to review the unit circle because we'll do the hand trick on some of the other ones. Those are going to be kind of small, but for radians, those are your quadrant angles. Pi over 2 is here, so we would just go 1 unit up. That would be the point, 0, 1. And then if we're using this unit circle for sine, you use y, and for cosine, you use x. So the cosine is what we're doing on this one, so the x coordinate is 0. So the cosine of pi over 2 is 0. So our x coordinate is 0. And then for the y, same thing, except we use the sine of theta. Alright, so the sine of pi over 2 is 1. That's going to be 4. So our rectangular coordinates are 4, 0. I said that backwards, sorry. 0, 4. And so those would line up at the exact same point. If you put the rectangular on top of the polar, they're at the exact same point. All right, then for B, x is going to be equal to 2 times the cosine of negative pi over 6. Now I want you guys to remember that cosine is an even function. So the cosine of negative pi over 6 is exactly the same as the cosine of pi over 6. All right, then if we want to find the cosine of pi over 6, we can use the hand trick. That is the pi over 6 finger. If we're going to do the cosine, it's going to be the square root of the top over 2. All right, and then when you multiply those, the 2's would cancel out. So the x coordinate is the square root of 3. All right, and then to find the y, we're going to do 2 times the sine of negative pi over 6. All right, and then I want you guys to remember that sine is an odd function. So the sine of negative pi over 6 is the same as the negative sine of pi over 6. All right, and we use the pi over 6 finger to find the sine. Is the square root of the bottom over 2. So that is negative 1. So the rectangular coordinates are going to be square root of 3, negative 1. So you go right square root of 3, and then down 1, and that takes you to the exact same point. Okay, one more. I'm going to change colors. All right, so x is going to be negative 3 times the cosine of 2 pi over 3. Okay, so 2 pi over 3 is in quadrant 2. Cosine is negative in quadrant 2, so we would change that to negative. And then the pi over, we would use the pi over 3 finger, which is this finger. And cosine is the square root of the top over 2. So your x coordinate is the coordinate 3 halves. All right, and then for the y, so again, 2 pi over 3 is in quadrant 2. Sine is positive in quadrant 2, so we'll leave it positive. And then we do the square root of the bottom over 2. So the y coordinate is negative 3 square root of 3 over 2. Alright, so that is your point. Alright, and then the last thing that I'm going to teach you this year is if we want to go from rectangular to polar. So rectangular, we have x's and y's. Polars, we have r's and thetas. So we start off with x and y's. We need to get r's and thetas. R is going to be the square root of x squared plus y squared. So the distance, basically the distance that point is from 0. That gives you your r. And then just a recap from what we did yesterday with your direction angles, is basically the same thing. We used a and b yesterday. Today we're going to use y and x. Or you could say that theta is the inverse tangent of y over x, either one. Okay. So now I did ask you all to plot the points. That kind of just helps you visualize it a little better. So first one is the point 2, 2. We want to get to that same point, but instead I want to use polar coordinates, which takes you directly to the point by knowing how far to rotate and knowing how far to travel. All right, so our r is going to be the square root of x, this is x and y, x squared plus y squared. Or square root of 8, which reduces down to 2 square root of 2. Right? For our theta, we know that the tangent of theta is equal to the y over the x. Alright, and then anytime we get a tangent of 1 or negative 1, we want the same number of top fingers as bottom fingers, which is the pi over 4 finger. Now, because this one is in quadrant 1, you do use the fingers on your hand. You don't have to use them as reference angles. So that's it. Oops. Those are the polar coordinates that take you to this point right here. All right, one more. So for this one, we're gonna move the square root of 3. I don't know exactly what the square root of 3 is, so let me check real quick. All right, so it's about 1.73. So I'm going to move about that to the left and then up 1. So this is the point I'm talking about right there. This one's going to be a little more challenging with our theta. Okay, but to find r is basically the Pythagorean theorem. So it's the square root of negative square root of 3 squared plus 1 squared. So that's going to be 3 plus 1, the square root of 4, or just 2. So r is 2. Alright, so we figured out how far we're going to move. Now we need to figure out what angle we need to take. So we know the tangent of theta is equal to 1 over the negative square root of 3. So if we're talking about the hand trick for tangents, that means we want one top finger. Oh, I said that wrong. Just kidding. We want one bottom finger and 3 top fingers. So it looks like this is our winner. It's the finger 5 or 6. But I hope you guys recognize that this angle right here is not the angle 5 or 6. This is the angle that's 5 or 6. So we need to think about what pi over 6 is in quadrant 2. And hopefully you guys remember that is 5 pi over 6. So our answer for this is 2, 5 pi over 6. All right, your assignment on this one is a little different because I know there's a printing issue some people have. So, and this one would have been kind of difficult to do if you didn't print because there's some graphing. So I have a Google form for you all to do, and it will tell you the right answer. If you miss it, it's not a big deal. So go ahead and complete that Google form. And I'll get back to you with the review. That's the last thing that we're going to do is the review. So once you finish this assignment, your spring break starts.